Have you ever used Login with Google and wondered how it actually works behind the scenes? The magic behind it all is a powerful service called an authorization server. This server has a set of specialized web addresses called endpoints, and each one has a very specific job. In this video, we're going on a guided tour to see exactly what each endpoint does and how they work together to keep your applications secure. At the heart of these protocols are endpoints, which are essentially URLs on an authorization server that our applications talk to. First, let's look at the foundation. OAuth 2.0. It has two mandatory endpoints that form the backbone of the framework. The authorize endpoint, which handles the user-facing part of the process. This is where the user logs in and grants consent. And the /token endpoint, which is a secure back-channel endpoint where our application exchanges credentials, like an authorization code, for the actual access tokens. Optionally, OAuth 2.0 defines an /introspect endpoint, which a resource server can use to validate a token and check if it's still active. Now, OpenID Connect, or OIDC, is a thin layer built on top of OAuth 2.0 specifically for handling user authentication. It adds several powerful endpoints. The well-known /jwks.json endpoint is crucial. It hosts the public keys that your application needs to verify the digital signature of ID tokens, proving they haven't been tampered with. The well-known /OpenID configuration endpoint acts as a map or a discovery document. It provides clients with all the necessary metadata about the server, including the locations of all other endpoints. The /userinfo endpoint is an optional but very useful endpoint where an application can retrieve more user profile information, like their name or email, using an access token. And finally, the /logout endpoint provides a standardized way to log a user out of their session. To really understand how this all works together, let's take a closer look at the most important endpoints in action. We'll start at the beginning, the very first step a user takes. So let's begin with the /authorize endpoint. As we just saw, this is the mandatory starting point for any flow that involves a user. Like the authorization code flow, think of this as the front door of the authorization server. It's where your application sends the user to formally ask for their permission to access certain data. The entire interaction happens in the user's browser. The process begins when your application constructs a URL and redirects the user to it. This URL isn't random, it's carefully built with several key query parameters that tell the server what's happening. Response_type equals code. This tells the server we are using the authorization code flow and expect a temporary code back. Client_ID. This identifies which application is making the request. Redirect_URI. This is a critical security parameter. It's a pre-registered URL where the server will send the user back to after they're done. Scope. This lists the specific permissions the application is asking for, like OpenID, profile, or email. These are shown to the user on the consent screen. State. This is a unique, random string generated by our application. The server must return this exact value back to us, which helps prevent cross-site request forgery attacks. When the user lands on this URL, they'll see the familiar login and consent screens, asking them to allow or deny the request. If the user clicks allow, the server sends them back to our application's redirect_URI, with the temporary code and the original state value in the URL. But it's really important to remember, this code isn't the access token itself. Think of it as a temporary single-use ticket. Our application server now has to cache that ticket in to get the real tokens. And that happens at our next stop, the /token endpoint. Following the user's consent, at the /authorize endpoint, our application now has a temporary authorization_code. The next critical step is to exchange that code for real, usable tokens. This exchange happens securely at the /token endpoint. Unlike the /authorize endpoint, this is a back-channel communication. It happens directly between your application server and the authorization server, hidden from the user's browser. As you can see in the table, the request your server makes depends on the grant type. For the authorization code flow, we send the code we just received, along with our application's client_endpoint and client_secret to prove our identity. In return, we get our powerful access token, and potentially an ID token and a refresh token, depending on the scopes we requested. The client credentials grant is different because there's no user. It's for machine-to-machine communication. Here, the application authenticates using only its own credentials to get an access token that represents itself. Finally, when an access token expires, we use the refresh token grant. We send the long-lived refresh token we've stored and get a brand new access token back, often along with a new refresh token for improved security. So think of the /token endpoint as the engine room, where proof of permission is turned into real power. But you might be wondering, how does my app know where to find this endpoint in the first place? That's a great question, and the answer is a process called discovery, which we'll explore right now. So we've seen how our application talks to the /authorize and /token endpoints, but this raises a big question. How does our app know the exact URLs for these services? Does a developer have to manually copy and paste them for every server they want to support? Absolutely not. And the answer is one of the most elegant features of OpenID Connect, the discovery endpoint. By navigating to a single, standardized URL /well-known /OpenID configuration, our application can get a complete map of the authorization server. This map is a simple JSON file that tells our app everything it needs to know to interact with the server. Let's look at what this map tells us. First, the issuer. This is the official name or URL of the server, confirming we're talking to the right authority. Most importantly, it lists the URLs for all the other key endpoints, like the authorization_endpoint and token_endpoint we've already visited. This is how our app finds its way around. It also tells us what scopes_supported are available, so our app knows what permissions it's allowed to ask for. The response_types_supported tells our app which OAuth flows, like the code flow, are enabled on the server. The claims_supported lists all the individual pieces of user information, like their email address or unique ID, that the server is able to provide. This lets our app know what data it can potentially receive. And critically for security, ID_token_signing_alg_values_supported tells our app which cryptographic algorithms the server uses to sign its tokens, so we can verify they are authentic and haven't been tampered with. By visiting this one single endpoint, an application can automatically configure itself to work with any compliant server on the internet. It's what makes OpenID Connect so powerful and interoperable. We've covered the core of how applications authenticate and get tokens. But what if your application needs more than just a user's ID? What if it needs specific profile details, like their name or email address? That's where the /userinfo endpoint comes in. This endpoint is a protected resource that holds standardized user profile information. Once your application has an access token, it can present that token to this endpoint to retrieve details about the authenticated user. It's designed to give your application just the information it needs based on the permissions the user has granted. Let's look at some of the common attributes you can get from here. First, the sub or subject claim. This is always included. It's the unique identifier for the user within the authorization server, ensuring you know exactly who this information belongs to. Next, for attributes like email and email_verified, your application needs to have specifically requested the email scope during the authorization process. If the user granted that permission, you'll receive their email address and whether it's been verified by the identity provider. Similarly, for richer profile details such as name, given_name, family_name, nickname, or even a picture URL, your application must have requested the profile scope. If granted, these fields provide the human-readable information your application might use to personalize the user's experience. The /userinfo endpoint is a fantastic way for applications to get necessary user details without directly accessing the identity provider's full user database. It reinforces the principle of least privilege, ensuring applications only get the data they specifically asked for and were granted permission to access. With a clear understanding of these fundamental endpoints, you now have a solid grasp of how modern authentication and authorization systems function. And there you have it, our guided tour through the essential endpoints of an OAuth and OpenID Connect authorization server. We began our journey at the /authorize endpoint, where users grant their consent. From there, we moved to the secure /token endpoint, the engine room where access and ID tokens are issued. We then explored the crucial /well-known /OpenID configuration endpoint, which acts as a dynamic map, allowing applications to discover all the server's capabilities. And finally, we saw how the /userinfo endpoint provides applications with specific, consented user profile data. Together, these specialized URLs form a robust and flexible system for secure authentication and authorization. They enable applications to access necessary resources while prioritizing user privacy and system integrity. Understanding how each of these endpoints plays its vital role is fundamental to building secure and compliant applications in today's interconnected world. Thank you for joining this comprehensive tour. We hope it's given you a clearer picture of how these critical pieces fit together.